Should we destroy Asteroid 2024 YR4 instead of letting it hit the moon? Why Hycean worlds probably don't exist. Liquid water once flowed on asteroid Ryugu. And in Space Bytes Plus, a supermassive black hole that is breaking the Eddington limit. All this and more in this week's Space Bytes. Earlier this year, astronomers announced that the asteroid 2024 YR4 had a non-zero chance of hitting the Earth in 2032. Now, that chance was very low, and as expected, subsequent observations decreased that chance to zero. But at the same time, the chances of it hitting the moon remained non-zero. And now the likelihood is that there's about a 4% chance of this asteroid hitting the moon in 2032. On the one hand, that would be awesome. Like, we would watch at the exact time and place as a 60-meter asteroid crashes into the moon. It'll create a bright flash. We will then get the mother of all meteor showers months later, as a lot of this debris rains down on Earth. That all sounds terrific, and I am here for it. But unfortunately, all of that debris will also be interacting with the satellites that are orbiting around the Earth and could cause damage and degradation and even take out satellites. Now, if we want to minimize the chance that it's going to harm our satellites, then we should either move it or destroy it. And in a new paper, researchers propose different ways that we could do both of those things. As we saw with the DART mission, we now have the ability to move asteroids. You send in an impactor, it smashes into the asteroid, it changes the orbit, and then over the course of subsequent years, what would have been a hit becomes a miss. But that requires a long lead time. So you've got to go quickly, and someone's got to go and build a mission and launch it immediately to be able to begin that process of shifting its orbit. The other way is to destroy it. Instead of having a single 60-meter asteroid, you have a collection of maybe 10-meter asteroids. That would require a bigger impactor, but is a relatively more straightforward mission, and you can do this at more of the last minute. And then instead of having a large amount of debris, you have a smaller amount of debris. You still get a meteor shower, but less risk to the satellites. And so in this paper, astronomers calculate which of these methods is the most likely, which ones would work at different times, and what we could expect. And if you want to learn more about this, we've got a story by Andy Thomaswick. I'm sure most of you are now familiar with the idea of Hycean worlds, or hydrogen ocean worlds. These are exoplanets about the size of Neptune with a thick hydrogen atmosphere and then an ocean of liquid water that is incredibly deep. The thick layer of hydrogen acts like a super greenhouse effect that keeps this water liquid even outside of what would be considered the habitable zone. These planets have been theorized to exist, and astronomers even think they've found a candidate, K2-18b. And in addition to that, researchers propose that they're detecting faint evidence of biosignatures in the atmosphere of K2-18b. That claim has been met with a lot of scientific skepticism, and so I wouldn't place a lot of credence that there is signs of life on K2-18b. And in fact, now new research suggests that K2-18b might not even be a Hycean world. Let's get this right. Is it Hycean or Hycean? You take hydrogen, ocean, hydrocean, Hycean. Okay. So one of the issues is that when you have a newly forming planet, it has a large interior of molten magma, and then that interacts with the liquid water that is on the surface of the planet, and that tends to destroy the water. It breaks it up into hydrogen and oxygen, bonds the oxygen with rocks, turns it into carbon dioxide, and the hydrogen is either pulled deep under the surface or can be allowed to escape through interaction with the solar wind. And over time, you would expect the amount of water on the surface of the planet to go down to about 1.5%, which is vastly less than is being predicted for these Hycean worlds. And so researchers simulated 248 different types of potential Hycean worlds, properly modeling the interactions between this magma interior and this water surface. And they found that in all of the cases, these planets get a lot drier. So it's not impossible. And of course, like with the Earth, if you had some source of water that was being delivered after the planet had cooled down significantly, then you could have a thick ocean on it. But if it's in that original formation time, things tend to trend away from it being able to have this thick layer of water on it. So according to the researchers, the likelihood of these Hycean worlds are out there is a lot lower than people were hoping. And then that means that there's less chance that there's life there. Now, there's a lot of evidence going back and forth. And so if you want to dig into it more deeply, check out this story from Evan Goff. But a place that there was liquid water is asteroid Ryugu. And this is a big surprise. This is a relatively small asteroid, just a few kilometers across, and yet, according to the researchers who were studying the samples that were brought back by the Hayabusa 2 mission, liquid water once flowed on Ryugu. Now, it's too small to actually have like oceans on its surface, but what the scientists think happened was in the past, it was struck by another asteroid, heated it up, and the ice particles inside Ryugu melted. Ryugu is a type of carbonaceous asteroid that has a very low density. So astronomers think that it has about 50% of its volume is just empty space. And so if there was a lot of water ice inside the asteroid, when it was heated up by some kind of impact event, then that water would have melted and then flowed inside the asteroid, going through various channels and gaps. And this is important. Partly this is just super cool that you can imagine at some point Ryugu had liquid water sloshing around inside of it. But this makes it a very exciting possibility as one of the sources for water to be delivered to Earth. That this asteroid formed early on in the history of the solar system, and yet within 1 billion years of its formation, it still had liquid water in its interior. Asteroids were generally discounted as sources of water for the early Earth because they are dry, that they're close to the sun, that the intense radiation from the sun should have dried them out, blown away all of the volatile gases and water off of them. And the water should have sublimated away from them. And so this is showing that in fact, the water wasn't sublimated away. It shows that it was still present in the asteroid for 1 billion years after it formed. And so could have been a viable source for delivering water to Earth. And so now you've got comets, you've got asteroids, you've got just potentially water that was there in Earth's orbit as it was starting to form as all potential sources to build up these oceans that we find on the Earth today. And we've got a story about this from Evan Goff. And then speaking of habitability, let's take a look at Mars. Now, Mars today sucks. It is cold, dry, bombarded with radiation. The top layer of the regolith is filled with toxic perchlorates. It is a very bad place. People want to live there. I'm not sure why. But in the ancient past, somewhere between 4.2 and 3.7 billion years ago, Mars was much warmer and wetter with a thicker atmosphere, potentially habitable. We know from many lines of evidence that Mars was a much better place in the past. They don't make them like they used to. But because Mars cooled down quickly, lacked a global magnetosphere, it didn't have a lot of gravity to hold on to its atmosphere, the ongoing interaction of the solar wind was able to push away a lot of the hydrogen in its atmosphere and dry the planet out. But thanks to the Perseverance rover, it's found evidence of many different kinds of minerals in the rocks that indicate times when the rocks were interacting with water. Researchers have found 24 different kinds of minerals that are produced through interactions between water and rock. Now, it was assumed that this was a one-way journey, that all of those minerals were formed early on, and then we get less and less of them as Mars dried out. But new research suggests that in fact they went in phases, that there was times of increased and decreased habitability, that Mars was relatively habitable, and then it went through a period where it was relatively uninhabitable, and then went back. And maybe this happened several times. Now, this is really difficult detective work to do on another planet using the Perseverance rover, which is currently in Jezero crater. It's collecting these samples. But we need those samples back to bring them to the labs on Earth to really piece together the history of Mars using these samples. So here's another vote for the Mars sample return mission, which is currently in limbo. And we've got a story about this by Matt Williams. Now, we know of 6,000 confirmed exoplanets in the Milky Way so far. And obviously this is just a fraction of the number of planets that are out there, but we know of exactly 0 confirmed exomoons. In other words, moons orbiting around planets in these other star systems. And like, obviously they're there. Like, there's so many moons here in the solar system. We will assume that they're out there, but you can't just take it on faith. You have to prove it. You have to find them. Now, there have been several methods proposed to actually find exomoons orbiting around other planets. One is that you use the radial velocity method, which is how we find exoplanets. And then you're looking for not only the changes to the starlight caused by the planet's gravity, but you're looking for even subtler variations coming from the moon that is orbiting around the planet, that is orbiting around the star. That is really tricky and probably outside the capabilities of any instruments we're going to have. The second idea is to use the transit method. So once again, you're looking for this time when the planet is passing in front of the star, and then you're looking for the times when the moon is contributing to the transit passing in front of the star. This is more exciting, and I know that various astronomers, including Dr. David Kipping, is working on methods to try and find exomoons using the transit method. But one new idea is that you can use astrometry. Astrometry is the technique used by the Gaia mission, where you're looking at the motions of stars as they move through space. And if the star has a planet orbiting around it, then it's going to cause the star to do a little spiral as it's moving through space. And that is caused by the gravitational tug of its planet. And if that planet has a moon, then you should be able to see the gravitational tug of the moon tugging the planet and its effect on the star. And this appears to be within striking distance of current instruments. So researchers looked at the gravity instrument, which is one of the instruments on the Very Large Telescope Interferometer. This is like the largest telescope on Earth today, and all where you have multiple telescopes working together as one. That gives you a 10 micro arc second resolution, which is maybe just enough to detect the presence of an exomoon around a large planet, like an Earth-sized moon orbiting around a gas giant planet. But there is an upcoming instrument called the Kilometer Baseline Interferometer that could reach 1 micro arc second precision, and that would make this kind of detection possible. And that would be enough to find Earth-sized moons orbiting around large gas giant planets around other stars. So in other words, think Andor, think Pandora. We've got a story about this by Andy Thomaswick. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner this week was the 3 robots that are going to work together to explore lava tubes on the moon. So thank you everybody who voted. By the time you're watching this, we will have posted the new vote to the post tab here on our YouTube channel. Of course, the best chance to see it, subscribe to the channel, click on the notifications bell, and then just vote on things in our channel until they start to show up thanks to the algorithm. All hail the algorithm. A new mission just launched, and it's going to take a picture of a faint halo around the Earth. The mission is called the Carruthers Geocorona Observatory, and it launched on September 23rd. And there's a really interesting story about this halo. So back in 1972, there was an Apollo mission that went to the moon, and the astronauts put a ultraviolet camera on the moon to then take a picture of the Earth. And it captured this faint image of a halo around the Earth. It's an image of the Earth's exosphere. And this is the outermost layer of the Earth's atmosphere. It's very difficult to see, barely detectable because it is so faint, and yet it probably extends out upwards of 10,000 kilometers away from the surface of the Earth, or maybe much more, maybe all the way out to the moon. And this is what we don't know. And so the Carruthers Geocorona Observatory is going to the L1 Earth-Sun Lagrange point. In other words, this is the Lagrange point in between the Earth and the Sun. It's then going to turn back and take pictures of the Earth for 2 years, trying to observe this exosphere halo around the Earth. And so 50 years after we got those first pictures from the moon, we should start getting new updated pictures of the Earth's exosphere halo. The first data will be coming in March 2026. We've got a story about this from Andy Thomaswick. Now let's give you an amazing picture from the James Webb Space Telescope. This is a massive stellar eruption coming from a protostar, a Herbig-Haro object called Sharpless-2 284. It's located about 15,000 light years away from us in the outer reaches of the Milky Way. This is a type of protostar, a Herbig-Haro object, and it is at a stage of its evolution where it is pulling together material, and these powerful stellar winds are ejecting material along its poles through these polar jets. And Sharpless 284 happens to be aligned so that we can see both sides of the jets, sort of 180 degrees apart from each other. This object is very interesting because it is metal poor, and so gives us an indication of what star formation might have looked like early on in the history of the universe. But it is also a beautiful picture taken by the James Webb Space Telescope. We've got more information about this by Matt Williams. Now, do you want more space news? One more story? Well, good news. We've got another version of this exact video with one extra story that we call Space Bytes Plus. It's over on Patreon, but it's completely free. There's no ads, and you don't have to log in or sign in or anything to watch it. And the additional bonus story this week is all about a supermassive black hole that is breaking the Eddington limit. It's feeding too fast. I'll put a link in the show notes. You can go watch that episode. And if you want even more space news, we are covering dozens more stories over on Universe Today. For example, Japan's Akatsuki Venus orbiter has completed its mission. How the galaxy's influence on the Earth can be found in crystals, and how a white dwarf is consuming a Pluto-like object. And these are just examples of the stories on Universe Today. I write them all up in my weekly email newsletter that I send out every Friday. I write every word. There's no ads. It goes out to 70,000 of my closest friends, and you can subscribe. Go to universetoday.com/newsletter to sign up. I'm going to talk about why our interviews are what you're looking for. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Carradwin, Chuck Hawkins, Commander Balog, Cy Nielsen, David Veribuff, David Gilton, David Matz, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Matter, Jim Burke, Jordan Young, Josh Schultz, Marcel Sutz, Michael Purcell, Monzo, Paul Roebuck, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fowler-Melly, Team 49, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. As I always say, I'm not a YouTuber. I am the publisher of the Universe Today website. I'm a space journalist. And the work that I do that I consider to be the most important is when I get a chance to interview researchers who are at the cutting edge of the work that they're doing. You're seeing all of the news. You're seeing things that have come out through press releases. People are explaining. It's on Wikipedia. People are using ChatGPT to boil it down. I'm talking to the researchers who are actually doing the work, who are the source of all of the news that you're seeing. And I try to interview 1 to 2 researchers every single week about the kinds of topics that I'm most interested in. I like to think about new telescopes, new solutions to difficult problems, exciting new discoveries in exoplanets, in astrophysics, black holes. I like to talk to people who are aerospace engineers who are working on new ideas to solve problems in space exploration, both human and robotic. I like people who challenge existing ideas or who are helping us understand concepts with more transparency. And so this is a bit of a paradox. You know, I see comments where people say, Space Bytes is too simplified. You go through this too quickly. You should spend more time detailing the research. That's what the interviews are. I see people who say the question shows are too simplified, that they already know the answers, that like these are dumb questions. They're questions asked by people who are still learning, who are still getting their footing in space and astronomy research. The interviews are at the cutting edge, at the very limits of my understanding about space and astronomy. And we are generally uncovering new information that you're not going to hear about anywhere else. And when you see the interviews and you see that it's going to take an hour to talk about some new idea for the solar gravitational lens, give it a chance. Trust me. Trust in my ability to do the interview, and trust that I've chosen someone who's going to be really interesting to talk to. For example, the interview that we just posted is this common complaint from people, which is like, why don't they just use some kind of electromagnetic shield to clean off rovers so the rovers don't die on Mars? And so I went and I found a researcher who's working on exactly this thing, prototyping it, and has results. And we're able to dig into why don't they just, or maybe they are just. So check out that. And then an interview that's coming up is the kind of idea that I really like, which is to come up with a clever solution for a difficult problem. What if we change the shape of a telescope mirror to be a rectangular strip so that it can view exoplanets orbiting around sun-like stars? Now you have to orient your rectangular strip, but if you get it right, then you get to have a much bigger telescope than if you tried to make a traditional circular shape. And we'll be releasing that interview on Monday. So keep an eye out for that. Check out the interviews. All right. We'll see you next time.